So today we're going to look at partial fraction decomposition. There are 4 different types of partial fraction decomposition. There are distinct linear factors, which is what we're going to work on today. There are repeated linear factors, and those two are the main two that you see partial fraction decompositions used or needed when it comes to calculus. But there are others, the third one being distinct linear and quadratic factors, and the last one is repeated quadratic factors. So this method of partial fractions was introduced by the mathematician John Bernoulli. And so it's not James Bernoulli, but John Bernoulli. They were both mathematicians. A decomposition is like the breakdown of something. So it's basically if you're looking at a fraction, we need to see how it is broken down into many fractions. And so usually it's the opposite. You've seen how many fractions, like more than one, like these two, added together and given one fraction in the ends. So we're going to first see how these two fractions add up and give you one fraction, and then we're going to decompose it. So in order to add these two fractions, they need a common denominator. X minus 1 cannot go into x plus 2. X plus 2 cannot go into x minus 1. They are distinct linear factors. Okay. So my first fraction, I'm going to have a common denominator of x minus 1 times x plus 2, which means I multiply the denominator with the quantity x plus 2, and need to multiply the numerator with the quantity x plus 2. And for my second fraction, I have already a denominator of x plus 2, so I need to multiply by the quantity of x minus 1. What I do to the denominator, I must do to the numerator. So they have a common denominator of x minus 1 times x plus 2. And our numerators we can now add up. So we have 3. I'm going to distribute it. This isn't so bad. So we're going to make a common denominator, and x minus 1 cannot go into x plus 2. X plus 2 cannot go into x minus 1. So both of them as factors are our common denominator. So that means that our numerators must be multiplied by the other factor. And now we can distribute and add up our numerators because we have a common denominator of x minus 1 times x plus 2. I'm sorry, the quantity of x minus 1 times the quantity of x plus 2. So we get 3x plus 6 plus x minus 1. So our final answer here is 4x plus 5 over. And I'm going to multiply out the denominator as x squared plus x minus 2. Okay, that's by distributing and using FOIL. So first terms are x squared, outer terms are plus 2x, inner terms are minus x. So that gives me plus x in the middle, last terms are negative 2. So the opposite of FOIL is factoring, and factoring is important. Everything you do in our courses, especially upper level courses of math. So it's a need to know kind of thing. We're going to need to know how to use that for the decomposition. Okay, so let's use this as our example, and let's pretend we do not know what its partial fractions are. So the first thing that we want to do is factor the denominator. So if we factor x squared plus x minus 2, our factors are x plus 2. So we get that positive x in one term and x minus 1. So these are what are being added to give us our original answer. I'm going to actually reverse this for a second. I like having my problem on the left-hand side. That's okay, because you're probably copying all the steps, and you should be copying step 1 and step 2 anyway. All right, so at this point, we're still on step 1. We need to let A and B represent the constants for the numerators. So I'm going to put an A here and a B there. They're usually capital when we're using, or we need to find the constants. So at this point, we're going to multiply both sides by the common denominator, what you were writing for step 2. Our common denominator is actually the x squared plus x minus 2. Okay, our answer from, or our denominator from our original problem. So we're going to multiply that to our first fraction. Okay, it's kind of distributing throughout each fraction. I feel like it's going to look really sloppy if I do this, but hey, it doesn't look too bad. All right, if we do that, that means that the denominators cancel out completely. This makes it easier to solve. Now, if we multiply it to our second fraction, A gets multiplied with the quantity of x minus 1, because remember, this factors as x plus 2 times x minus 1, so one of them gets canceled. And B gets multiplied with x plus 2, because again, this gets factored as x plus 2 times x minus 1. So I'm just going to use the green here. These would end up being canceled, multiplied by 1. Okay, please use this procedure, okay, to always figure out what you get for your next step. Because, okay, and this is actually part of it, because in other methods or other types of partial fraction decompositions, you may get the wrong answer if you think of it any other way. Please do not think of it as cross-multiplying. You cannot cross-multiply unless you have 2 fractions, one equal to the other. We don't have that. We have 3 fractions. Secondly, it's going to mess it up for the other problems. So please remember to multiply it out and cancel. All right, so I want to neaten that up and go on to step 3. So this is collect like terms on the right-hand side and match up terms and equate coefficients. It's a lot of things here. So the left-hand side is pretty simple. The right-hand side, we do have to distribute out the A and the B and like terms. So we have here AX and a BX. A and B are some numbers, we don't know what they are. So we can rewrite that as our constant. Like let's say if we did know this was going to be 2x and 3x, this would be 5x. Please put the constants before the variable. Now this over here are constants by itself. Let's say if we did know that number, that would equal a constant. We usually put that last. So we're going to match up terms and equate the coefficients. The left side of the equation, we have 4x. Okay, so 4 is being multiplied by x. And the right side of our equation, the quantity of a plus b is multiplied by x. That means that they must be equal. And similarly, our constant here of 5, and that expression that's supposed to be our constants, should be equal. This is an equation. So what happens here is that we set up a system of equations. Now we're up to number 4, and we're going to solve that system of equations. Okay, so since step 4 is to solve the system of equations, you can use any technique to solve the system of equations. You can use matrices because it's set up as a system of linear equations here. You can use the method of elimination, which is actually what I'm going to use right now because the A's can get eliminated. Or you can use substitution. So no matter which way that you solve, you're solving for A and B. In this case, I'm solving for B first. That's okay. And then I'm solving for a. And a turns out to be 1. So that means that I have to write my answer, that's step 5, my partial fraction decomposition. This is not my final answer. Once I find a and b, now I can write, hey, that 1 is over x plus 2, that's because I found a to be 1, and b, which is 3 is over x minus 1. This is my partial fraction decomposition. Okay, right here. And I didn't know I could move the screen like that. I don't know how to move it back. That's okay. We wrote our answer, we're done, and you should be good to go.